Alright, this is section 6-3, proving that a quadrilateral is a parallelogram. Okay. There is no new theorems in this section. If you've looked in the book already, theorem 6.5, 6.6, 6.7 are all the same theorems that you just did in the last section. It's just that they're written backwards. They're the converse of it. So instead of assuming that it's a parallelogram and a property, you're having to put the property in order to say it's a parallelogram. It's just backwards. I'm just going to write one quick proof down for you just so you can kind of see how they're going to work. Some of it will incorporate some triangle congruence, but the majority of your problems is going to be similar to what you did yesterday. Okay, so I'm going to just show you one quick proof, and then I'll show you one example in with it. Alright, so theorem 6-5 says both pairs of opposite sides quadrilateral congruent, then the quadrilateral is a parallelogram. I'm trying to prove that. I know I said that really fast, so let me say that again. If both pairs of opposite sides quadrilateral are congruent, then the quadrilateral parallelogram. So this is that theorem that we had yesterday that said the opposites were congruent. We're trying to prove that that means parallelogram. So the way this proof is set up for you, it says given xw is congruent to zy and xy is congruent to z. Okay, the picture is just a parallelogram, and this is x, y, w, z. And the reason why this has been is because we're supposed to assume that the sides are congruent, and then we're trying to prove that it is a parallelogram. And we are not allowed to use the theorem in its own proof. The only thing we can go is the definition. Okay? The definition says that if, in order for this to be a parallelogram, that the opposite sides are parallel. So what we're trying to prove, we're trying to prove WXYZ is a parallelogram. But we're going to do that by proving that the opposite sides are parallel. And here's how this is going to work. Okay, to do the proof, we're going to draw in one of the diagonals. Okay, anytime you're doing proof of a quadrilateral, it's most times, not 10 times, it'd be convenient to break the shape up into triangles, because we know how to do triangles. Triangles is the basis of everything. So when you break it down into triangles. So I'm not going to recopy this down, but if this would be moved here, that would be your given statement. Okay. Alright, now we know that xz is congruent to xz by reflexive, which makes the triangles congruent by side to side, because again we have two given statements. We knew that was congruent to that, this one was congruent to that one, and we just said it was congruent to itself. So that makes side, side, side. Okay. So that tells us that angle WXZ is congruent to angle YZX, and it's by PC to C. Because anytime the triangles are congruent, and that makes all of their parts congruent, because corresponding parts of congruent triangles are congruent. I did this backwards. CPCTC. Corresponding parts of congruent triangles are congruent. Alright, what do you notice? If I extend two lines, what angles are these? Those are alternate interior angles. So XY must be parallel to WZ because of interior angles. Now, I can do the same another set of angles. Angle WZX is congruent to angle YZ. That's also by CPCTC. This time we're talking about WZX. We're talking about this angle and that angle. Okay. Alright, hold on. Oh, I did this backwards. Okay, hold on. WXZ. So, go back to this step. I'm going to highlight this so we can see it. There's lots of letters on, so you got confused. If those two are congruent, then that would make XY. That would make these lines parallel. If those are lines formed by those two angles. So that would make XW parallel to YZ. Okay. Yeah, I just put the wrong line in the book. I'm sorry. For a second there might have been a typo in the book, but that wasn't the case. Alright, these two angles are formed by those lines. Okay? And then these angles, the purple ones, are formed by those parallel lines. So XY is parallel to W, also by AIA. And I just proved that both sides, opposite sides were parallel is the definition of a parallelogram. So XYZW is a parallelogram by definition of parallelogram. I'll let the whole word out. Parallelogram. Okay? Again, you are not going to have very many proofs in your homework at all, I promise. Maybe one or two. I'll help you with them in class. The majority of your homework, big majority of your homework, is going to be more similar to this. It's really based exactly what we did yesterday. So you should be really good at it by the time. A plus 40 and A 3 minus 3 C plus 1. Now this looks exactly like you did yesterday. You're going to be setting stuff to equal or supplement or whatever in order to get the shape to be a parallelogram. The only difference is the question is going to be worded a little bit different. Yesterday the question told you that it was a parallelogram. It said solve variable. This one's going to say find the variable that makes it a parallelogram. It's really the same thing. Okay? Whatever value gives you equal sides is the value that makes a parallelogram. Okay? So we know that sides are parallel are congruent. So 3C minus C equals C plus 1. Add the 4. 2C equals 5. I did something wrong. It would have been 4. Oh, sorry. Getting ahead of myself. Plus 3 gives me 4. That's where my 4 came from. Divided by 2, just 2. Now, big mistake a lot of we're going to make is you're going to set these equal. Are they equal? Let me do this. Look equal. Do not ever leave your common sense at the door. Yes, you're not supposed to assume things, but common sense can still give you hints about this. This is a very large angle. It's bigger than 90 degrees. And this one is very small. There is no way that those angles would be equal. Okay, they're not equal. Remember, these are those consecutive angles we talked about. So what do we do with consecutive angles? They add up to 180 because they happen to be same side interior angles. Combine your like terms. Move the 40 over. And divide by 2. And there is your answer.